Alright, so welcome to your level 4 video. And this is all about distance and the distance formula related to lines. And so for number 1, it says calculate the distance between point P, which is at the point 4, 2. So let's plot that. Here's point P, and the line y is equal to 10, which is this horizontal line up here. And so when I say calculate the distance, we're talking about the shortest distance. And the shortest distance from a point to a line is the perpendicular line that goes to the line given. So going perpendicular from point P to that line, we can just count 1, 2, 3, 4, 5, 6, 7, 8. 8 units. Now, it's not always going to be that easy, and we're going to talk about what to do in a situation like this one where we won't be able to count. But again, this falls underneath the parallel and perpendicular line standard because, again, the shortest distance from a point to a line is the path that's perpendicular. So we know how now to find what a perpendicular line looks like. And then also we're going to do problems like these where it says calculate the distance between the 2 points. So for example, for this one, I'm gonna plot the point 3, 7. And I'm going to plot the point 10, 1. And we want to calculate the distance between these 2 points. Now, last year we learned how to do this using the Pythagorean theorem, which the Pythagorean theorem is when we connect these 2 points with a vertical and a horizontal line, so two perpendicular lines, to create this right angle right here. And then counting, my vertical line is 1, 2, 3, 4, 5, 6 units long. And my horizontal line is 1, 2, 3, 4, 5, 6 units long. And so we can use the Pythagorean theorem to help us find the distance between these 2 points. So using a squared plus b squared equals c squared, c is the one we're trying to find. And so a 6 squared is a 36, plus another 6 squared is a 36, and that equals c squared. And you wind up with 72 is equal to c squared. And we take the square root of both sides. I didn't tell you whether to do this in simplest radical form or whether to round and type this into your calculator, so we're going to review both ways. So if I asked you to do this in simplest radical form, remember what we do is we split 72 up into its largest perfect square factors, which, remember, the perfect squares are 4, 9, 16, 25, 36, and so forth. This 72 is divisible by 36, so we can, 72 divided by 36 is a 2. So we can split 72 up into the square root of 36 times 2. And then we take the square root of 36, which is a 6, and the square root of 2 cannot be done. So c is the distance of 6 root 2. Now if I asked you just to round to the nearest hundredth, let's say, what you would do is you would just type in the square root of 72 in your calculator by doing second and then that x squared button. And we would wind up with c being approximately equal to 8.49 if I asked you to round to the nearest hundredth. Okay, but this is not the only way that we can find the distance between 2 points. In fact, there is a way that we can do it just by having these 2 points here and not using the Pythagorean theorem, and that's called the distance formula. The distance formula is something you are going to need to use and know. And so D stands for distance. And the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Now what's nice about the distance formula is if you switch the x1 and the x2 around and the y1 and the y2 around, it does not matter because you will be squaring that number. So no matter what you end up with, you're going to end up with a positive number. So if you flip those around, no big deal. Order doesn't really matter in the distance formula. But I do expect you to remember the Pythagorean theorem, how to find the distance between 2 points using the Pythagorean theorem. And I also expect you to know the new distance formula, so you will need to know this formula. All right, so if we move on to number 3, it says use the distance formula to find the distance between these 2 points. I'm going to label my 2 points x1, y1, and x2, y2. And now we're going to use the distance formula, which is b is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So first, we must follow the order of operations, which says to simplify the parentheses. So 14 minus 9 is a 5, and then we can square it. So a 5 squared is a 25. And then plus an 18 minus a 5 is a 13, and a 13 squared is a 169. Now students are always tempted at this point to do the square root of 25 and the square root of 169, and then add the two numbers together to get a distance of 18. However, that's not the correct way to do it, because technically, if we follow the order of operations, there's technically parentheses around this 25 plus 169 that we would need to simplify before we do the square root. So that gives you the square root of 194, which again, I did not ask you in simplest radical form or rounded, so we're going to do both again. If I asked you for simplest radical form, actually, this is as low as you can go because there is no perfect square factor of 194. But if I asked you to round to the nearest hundredth, it would be a 13.93 after putting it into our calculator. All right, so moving on to number 4 and 5, which was pretty similar to number 1. However, this time we won't be able to count the distance. So it's going to be a little more complicated and a little more work, but let's go ahead and get started. So we want to find the distance between point P, which is at 4, 2, so I'm plotting that right now, and the line y is equal to -6. So that means I have a slope of, y-intercept of -6, so I plot a point at -6 on the y-axis, and a slope of 1, so up 1 over 1, up 1 over 1, and keep going. And so I want to find the distance between this point P and this pink line. And how I'm going to do that, a reminder that the shortest distance between a point and a line is the perpendicular line. So between point P and the pink line, I need to travel perpendicular to that line. Okay, so I am going to need to know or to find the blue line. It's going to be the perpendicular slope compared to the pink line. Okay, and so if I do the perpendicular slope, the pink line had a slope of 1. The perpendicular slope of that blue line would then be -1, opposite reciprocal. Okay, and so what I'm going to need to do is I'm going to need to find where the pink and blue line intersect, which is right here. Once I find that point of intersection, which actually we're going to do not just by looking at the graph, because this one does work out nicely, but not all of them will. So I'm going to show you the process that you do to do this. But once I find that yellow dot, I will then use the distance formula to find the distance between point P and that yellow dot. Okay, Now, to find the intersection point between that blue and that pink line, that yellow dot, when we're always finding an intersection point, we use system of equations. So I need to find the equation of that blue line. The blue line has a slope of -1 because it's going to be perpendicular to the pink line, and it's going to go through point P. So let's write our equation in point slope form. Y minus y1 is equal to my slope of -1 times x minus x1. Now I want to find the intersection point between my pink line, which is this one that I'm circling now, and my blue line, which is the one that I just created. And in order to do that, what we can do is we can take, since y equals x minus 6 in this equation here, I can take that x minus 6 and substitute it in for y in my other equation. So I have an x minus a 6, and then I have that minus 2 is equal to a -1, x minus 4. And now I'm going to solve this equation for x. So combining like terms, I have an x minus an 8. Distributing this -1 in, I have a -1x plus a 4. Now adding this 1x over, I have a 2x minus an 8 is equal to a 4. And then adding 8 to both sides, I get a 2x is equal to a 12. And then dividing by 2 on both sides, x comes out to be 6. Now that x is just the x value of the intersection between this pink and blue line. But I need to find the y value of that point too. So what I'm going to do is I'm going to take this 6 and I'm going to put it in for x in this equation up here, and to get the y. So I have y is equal to a 6 minus a 6, which ends up coming out to be 0. So what that means is that that yellow dot is at the point 6, 0. So now I can find the distance between point P and that yellow dot by using the distance formula. Distance equals, I'm going to label point P x1, y1, and the yellow dot x2, y2. So my distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. And so I wind up with the square root of a 6 minus a 4 is a 2, squared is a 4, plus a -2 squared is a 4. So I wind up with the square root of 8, which if I asked you to put this in simplest radical form, we can split 8 up into a 4 times a 2. So this would be a 2 root 2 because the square root of 4 is 2. Or if I asked for this rounded to the nearest hundredth, you would do the square root of 8 in your calculator, and you would get about a 2.83. So number 5 is this same exact thing. I'm going to have you pause the video and try that one on your own. Okay, so running through this, I plotted point P and the line y is equal to -1/2 x minus 8. And I want to find the distance between point P and this yellow dot, which would be the blue line. I need to find the blue line that travels perpendicular to the pink line. So perpendicular to the pink line would give me a slope of 2, and the blue line equation in point slope form would be this, because it goes through point P. Then, to find the yellow dot, I need the intersection between that blue and pink line, so I use systems of equations. I did systems by substitution, so I took the -1/2 x minus 8, and I put it in for y in this blue equation, and I got this pink equation. When I solved for x, which is all this work right here, I got x is -4, which I then took and I substituted it into this equation up here to find my y value, which is -6. So the yellow dot is at -4, -6. I then use the distance formula between point P and the yellow dot, which is right here, And I got the square root of 125, which reduces to a 5 root 5, or if I asked you to round to the nearest hundredth, 11.18.